Okay, prepare yourself. We're about to go on a journey that makes, well, all of human history look like
Yeah.
less than a blink of an eye.
hmm
We are diving into the future of the universe on a scale that's almost, it breaks your brain, doesn't it? Quintillions of years and way beyond that.
Yeah, it's a deep dive into cosmic changes that are incredibly difficult to grasp.
Yeah.
We'll be looking at what happens to stars, galaxies,
Right.
and asking that huge question, where do humans fit in, if anywhere? And we're pulling all this from that fascinating source material you shared.
That's right. So our mission today is to unpack these sources, grab the key takeaways about these huge cosmic shifts, and try to make sense of it all for you. And just to start, let's talk about that number, 10 quintillion years.
It's staggering.
It really is. That's a 1 with 19 zeros after it. 10 billion years. I mean, how do you even visualize that?
You almost can't. But the sources, thankfully, guide us through this immense future, piece by piece.
Okay, so where do we start? Our journey begins, relatively speaking, kind of soon. Let's jump forward just 1 billion years.
Well, the picture for Earth isn't pretty. Forget the blue marble.
Yeah.
The sources describe it as dull brown, dry, basically a dead rock, no life.
Wow. Why? What happens?
It's our sun. It just keeps getting hotter very gradually, about 1 degree Celsius warmer every 100 million years. So by a billion years from now, Earth's average surface temp hits around 47 Celsius. That's, 117 Fahrenheit?
Ouch. That doesn't sound survivable.
No. And that heat completely messes up the carbon cycle, the thing life depends on.
Right.
Plants die first, then the animals that eat them. The oceans hang on and maybe a bit longer, boiling away, but eventually they evaporate too, just gone.
A completely barren world.
Yeah.
So that's grim for Earth. But what about humanity? Do the sources give us any hope? Do we make it?
Well, yes and no. There's hope, but it comes with a huge condition.
Yeah.
We would have to have left Earth long, long before this point.
So becoming spacefarers,
Yeah.
colonizing other planets, maybe way out there.
Exactly. That's one path the sources talk about. Finding new homes far away from the sun, maybe even temporarily setting up shop on, say, moons in the outer solar system where it's colder.
Then material also brought up that other idea, right? Humans as like pure AI, uploaded consciousness.
Yeah, that's floated as another theoretical way to survive. But, and this is a key point the sources make, even AI needs power.
Ah.
Huge amounts of power. You'd still need physical systems, physical infrastructure, probably set up by physical humans initially, just to keep the lights on for those virtual minds.
And that's where the source material makes this really interesting connection back to us now. It says this massive future energy need. Well, it highlights how critical energy solutions are even today.
It does. It's quite neat how they link it. They use this future challenge to sort of spotlight companies working right now on things like super efficient energy conversion.
Yeah.
They mentioned, for instance, Hillcrest Energy Technologies and their Xevious inverter tech.
Zero voltage switching. And the big deal there, according to the sources, is the efficiency, right? Converting DC power, like from solar to AC power, with almost no loss, like 99.7%.
Exactly. And that kind of extreme efficiency isn't just, a nice to have. It's fundamental if you want to maximize every single watt you can get, whether it's from solar panels today or who knows, maybe exotic energy sources billions of years from now. It could make renewable projects more profitable, maybe even shrink EV batteries and costs.
It really underlines how solving these fundamental energy problems now, it's almost like step one on any possible path to long-term survival out there.
It's a very grounding point, I think. It connects our present tech challenges to these almost unimaginable futures.
Absolutely. Okay, but let's keep moving through time. We've dealt with Earth's rather bleak fate at the 1 billion year mark. Where do the sources take us next?
Right. Let's jump much further ahead, 10 billion years into the future.
Okay.
By now, our solar system is toughened. Well, it's fundamentally changed. Our sun's main life is over. It's now a white dwarf.
So tiny, like Earth-sized, but super dense and hot. Yeah.
That's right. The sources explain that in the preceding time, it burned through all its core hydrogen. It swelled up into a huge red giant first.
Oh, that's when it engulfs the inner planets?
Yeah, it would have definitely swallowed Mercury, Venus, and probably cooked Earth right down to its core. Maybe vaporize it entirely before shrinking down into that white dwarf. And then it just sits there, cooling for trillions more years.
Okay, so our sun's basically retired. But while that's happening, something even bigger is going on nearby, right? On a galactic scale.
Oh, yes. Around the same time, give or take, The Milky Way and our neighbor, the Andromeda Galaxy, are set to collide.
Collide, like head on.
Will merge, really. They're the biggest galaxies in our local group, and gravity's been pulling Andromeda towards us at something like 400 billion kilometers an hour for ages.
Wow. The sources had that analogy, didn't they? Like being inside a snow globe, being shaken violently.
Yeah, but instead of snowflakes, it's stars, planets, gas clouds, all swirling around.
So they combine into one massive galaxy. Milkomeda, they call it sometimes.
That's the idea, Milkomeda. But it's important, and the sources stress this. Individual stars probably won't actually collide.
Really? With all that chaos?
Yes, space is just that big. The distances between stars are enormous, even inside galaxies. So they'll get thrown around by gravity, orbits will change wildly, the whole structure gets reshaped, but the stars themselves mostly just fly past each other.
Okay, that's slightly less terrifying. But what about our solar system? Or what's left of it with the white dwarf sun? Does it survive the merger?
Well, the calculations mentioned in the sources give a few possibilities. There's about a 50-50 chance our solar system gets flung way out, maybe 3 times further from the new galactic center than we are now.
And the other possibility?
There's about a 12% chance it gets kicked out of the new galaxy entirely, just ejected into intergalactic space to become a rogue system.
Wow. So again, if humans are still around by then...
They really need to have moved house. Spread out across other star systems, probably long before this galactic smash-up happens.
Right. Okay. 10 billion years. White dwarf sun, new mega galaxy. What's the next big milestone on this cosmic calendar?
The sources point towards something around maybe 22 billion years from now. And this one's, well, it's a potential universe ender. It's called the Big Rip.
The Big Rip. That sounds final. What causes that?
Dark energy. You know, that mysterious stuff making the universe expand faster and faster.
Yeah, accelerate.
The Big Rip theory basically says, what if that acceleration doesn't just continue? What if it runs wild, gets stronger and stronger until it literally tears everything apart?
Tears. Everything. Like galaxies, stars.
Everything. First, it overcomes gravity, holding galaxy clusters together, then galaxies themselves, then solar systems get pulled apart, planets ripped from stars, and in the most extreme version, it could even overcome the forces holding atoms together.
So it shreds matter itself down to the subatomic level.
That's the idea. Just
a little wild.
Solution, total chaos. But the sources are quite clear. It's still very theoretical. There's some evidence consistent with models where this could happen, depending on how dark energy behaves, but it's absolutely not certainty. More like a worst case scenario based on some possibilities.
Okay, let's hope that one stays theoretical. Assuming the universe avoids ripping itself to shreds, what's next? Where do we go if things just keep winding down?
If we avoid the Big Rip, we need to jump much, much further ahead. Our next major stop is 100 trillion years from now.
100 trillion. Okay, what happens then?
This marks a really profound moment. The end of the stelliferous era.
Stelliferous. The age of stars. The time when stars are actually shining.
Exactly. It ends because basically star formation across the universe grinds to a halt, and the existing stars are burning out.
Right. Stars form from gas clouds, hydrogen mostly.
And how long they live depends massively on their size. The sources recap this well. Huge stars burn incredibly bright, but fast, maybe only millions of years.
Like cosmic Ferraris.
Sort of, yeah. Our sun's more average lasts about 10 billion years.
Yeah.
But most stars are actually smaller red dwarfs.
And they last much longer.
Oh, way longer. Trillions of years, potentially. Maybe 80 to 100 trillion years for some. They're incredibly frugal with their fuel, but even they start dying out around this 100 trillion year mark.
And the universe isn't making new ones to replace them. Why not?
It's run out of the raw materials. That diffuse hydrogen gas needed to kickstart star formation just isn't available in the right conditions anymore. Dying stars recycle some material, sure, but it's not efficient enough. The universe's star-making fuel tank is basically empty.
So 100 trillion years. The lights really start going out across the cosmos. Which brings us to that first huge number we mentioned, 10 quintillion years.
Right, and welcome to the degenerate era.
Degenerate era. Sounds bleak.
It is. The universe is vastly dimmer now. It's essentially a cosmic graveyard filled with the corpses of stars.
White dwarfs, brown dwarfs, neutron stars, black holes. Just the leftovers.
Exactly. Star formation is over. The universe is just cooling, darkening, getting more empty in a way.
Is anything happening at all? Any sparks left?
Very rarely. The sources mention you might get occasional collisions between these stellar remnants, like two brown dwarfs could smash together and maybe ignite as a new, dim star for a few trillion years.
Wow.
Or two white dwarfs could collide and trigger a type Ia supernova.
Yeah.
But these are incredibly rare events in an overwhelmingly dark and quiet universe.
So the main trend is just cooling down, things falling apart.
Yes, cooling and increasing entropy. And on these timescales, something even more fundamental might start happening, the decay of matter itself.
Wait, matter decaying? Like the protons and neutrons that make everything up?
Potentially, yes. We have to jump even further forward now, almost beyond imagination, to around 10 decillion years. That's a 1 followed by 34 zeros.
Yeah.
This is when some theories predict proton decay could become significant.
Protons, the core of atoms, they might not be stable forever.
According to some grand unified theories, maybe not. Over absolutely colossal timescales, they could just disintegrate into lighter particles.
And if protons decay, what does that mean for all those white dwarfs and neutron stars?
It means they slowly dissolve. They'd fade away, maybe emitting just a tiny bit of energy, like the brightness of a couple of light bulbs, as their very substance evaporates over trillions and trillions more years.
That process sounds incredibly slow.
Unbelievably slow. The predicted half-life of a proton is vastly longer than the current age of the universe. But if it does happen, well, it implies that even the fundamental building blocks aren't permanent. The universe seems destined for emptiness.
Which leads us, I guess, to the era dominated by the things that last longest. We need another jump in time.
A big one. To 10 duodecillion years. A 1 with 40 zeros.
Duodecillion. Okay.
Now we enter the black hole era.
Because they're the only things left.
Pretty much. The universe is incredibly dark now.
Yeah.
Any remaining stellar remnants are decaying or have been swallowed. Black holes, having spent eons consuming matter and energy, are the dominant objects. Massive, dense, and dark.
The ultimate cosmic vacuum cleaners. But hang on, didn't the sources say even they don't last forever? Something about Hawking radiation.
That's right. It's a fascinating theoretical concept. Stephen Hawking proposed that black holes aren't perfectly black. They should slowly leak radiation over immense periods.
How does that work again? Something about particles near the edge.
Yeah, the simplified idea is that pairs of virtual particles constantly pop into existence near the event horizon. Usually they annihilate each other instantly, but sometimes one falls into the black hole and the other escapes.
And the escaping one carries energy away.
Exactly. It effectively takes a tiny bit of the black hole's mass with it. So over truly astronomical timescales, trillions upon trillions of years, even longer for supermassive ones, the black holes slowly evaporate.
Wow. Even black holes die.
Yeah.
So after the last black hole evaporates, where does that leave us? What's the absolute end game, according to the sources?
We finally reached the deepest future discussed. A Google, years and beyond.
Google? A 1 with 100 zeros.
Welcome to the dark era.
What's that?
Anything. Almost nothing. The last black hole has fizzled out. All matter has either decayed or been radiated away. What's left is maybe some stray subatomic particles, photons, stretched to almost infinite wavelengths by expansion, neutrinos, maybe some electrons and positrons, incredibly spread out in a vast, cold, dark void, and dark energy still pushing everything apart.
Just cold, dark silence, forever expanding.
That's the leading theory, yeah. The big freeze, or heat death. Dark energy keeps driving expansion. The universe cools towards absolute zero. Energy gets evenly distributed. Maximum entropy. No more change. No more work possible. Just stillness.
The sources mentioned another possibility, though, didn't they? The big crunch. Less likely, maybe?
Right. The big crunch. That's the idea that maybe expansion could reverse one day. Everything comes crashing back together, maybe into another singularity, potentially triggering a new Big Bang, a cyclical universe.
But current evidence points more towards the freeze.
Based on what we know about dark energy and the accelerating expansion, yes. The big freeze seems the more probable fate described in the material.
Okay. So, endless cold and dark seems the most likely scenario presented. Let's circle all the way back then. After this incredible journey, what does it all mean for us? For humanity? The sources seemed pretty clear that life as we know it has a tough time after the stars go out.
Yeah, things look decidedly bleak for complex biological life once the stelliferous era ends around 100 trillion years. Luminous stars seem pretty essential for creating habitable zones, for providing the energy needed. It's hard to see how life like ours survives naturally beyond that.
There was that final twist, wasn't there? The sources didn't just end with cosmic doom and gloom. There was this other idea.
Ah, yes, the really mind-bending part. Despite the seemingly inevitable decay of this universe, the sources raise this speculative, intriguing possibility.
Go on.
That maybe intelligence itself, humanity, or whatever we evolve into, could become so advanced, progressing through those hypothetical Kardashev scale types, mastering energy, maybe even space-time.
To the point where...
To the point where we might learn enough to actually build our own universe. Create a new reality, perhaps even in a lab, escaping the fate of this one.
Create our own universe after charting the decay and death of this one. That idea is just staggering.
It's certainly a wild thought.
Yeah.
But it represents a kind of ultimate hope, maybe? A way for consciousness or intelligence to potentially transcend the natural life cycle of the cosmos we've explored. It really pushes the boundaries of what we think is possible.
Wow. Okay. We have traveled an almost unbelievable distance through time today. From a dying Earth just a billion years out, through galactic collisions, star death, matter decaying, black holes evaporating, all the way to the potential final cold darkness, or maybe even a new beginning.
It's been quite the tour. This deep dive really pulled out some key insights from the sources about how stars live and die, how galaxies evolve, the huge role of dark energy, and these potential ultimate end states for everything.
And it absolutely leaves us with that final provocative question from the material, doesn't it? Thinking about these almost infinite timescales, this potential cosmic end. What does it really mean for us here and now? And how does that far-out idea of potentially creating our own reality change how we see our place in this universe?
It's definitely a lot to chew on, a perspective shift for sure. Makes you think about our little moment in cosmic time very differently.